Here we discuss about oscillations. We know that the way an object moves is decided by the force acting on the object, and one can find out the motion of the object using the Newton's second law of motion, that is the force is equal to ma. This is an equation which is a vector equation, and we can talk about motion in 1 dimension, 2 dimension or 3 dimension. And we know from the subject of projectile motion that we can analyze projectile motion, that we can analyze a 2-dimensional motion as a combination of 1-dimensional motion. That is, we treat projectile motion, we treat the vertical motion due to gravity, and the horizontal motion, there is no force acting on the horizontal. So we solve the equation of motion for vertical motion as well as the horizontal motion. In case of horizontal, we know, suppose if we take the horizontal displacement as x, and v is the velocity in the direction horizontal, or suppose if a projectile, let us take specific example as a projectile which is fired at an angle theta with velocity v, then this is v cos theta, and this is the vertical velocity is v sin theta. And we know the acceleration for the vertical is acceleration due to gravity. If we take this up as a positive, then we take for the x, it is v cos theta into time. This gives us the motion for the horizontal motion, and then y is v sin theta t minus of gt square. This describes the motion in the vertical direction. So we take the reference point from where it is thrown up to be x is equal to 0, y is equal to 0. So we can think of projection from some other height. So now by eliminating t from both the equations, we get the equation of motion, which is a parabola. So the projectile follows a parabola. So we can also discuss the another example in 2 dimensions is the uniform circular motion. So let us take a uniform circular motion. This is a circle with a radius r. And here let us take uniform circular motion is the speed is constant, the velocity is changing. Let us talk about speed v, and if this is an angle theta. So the position of the x coordinate, we can discuss about the position of the object in terms of its x and y coordinates. So this is the x coordinate, and this is the y coordinate when the object is at this point, let us say A. So this gives us x is equal to r cos theta and y is equal to r sin theta. Now we see as the object moves in a circle, the practical example of uniform circular motion is like Earth moving around the sun being at the center, the r being the radius between the distance between the sun and Earth. So we have the x and y coordinates given by x is equal to r cos theta, y is equal to r sin theta. Theta is the angle. Now if we take we start analyzing motion when the object is at this point at t is equal to 0, then we will find that theta, if the velocity of the object moving is v, then we know that v is equal to r, and omega is the angular velocity. V is equal to, so this is a capital here, or omega is the angular velocity, and r is the radius. So omega is nothing but theta by t. That gives us the angular velocity, which is again constant. When we say the linear velocity is linear speed is constant, then the angular speed also is constant. So v is equal to r omega. So this gives us x is equal to r cos omega t, and y is equal to r sin omega t. Now with respect to t, as we see the theta is at different values of theta, we can see theta is 0, pi by 2, then we have pi, then 3 pi by 2, then we have 2 pi. This completes one revolution of the object in the circle. So at these angles, the value of x is r. Here it is 0, x is 0, and here it is minus r, here it is 0, here it is r. So 3 pi by 2 corresponds actually to this point, and this corresponds to pi, and this is again 2 pi. Now we can see y goes, this is 0, then when it comes pi by 2, this is r, and then we find when it comes here again it is 0, and when x is 0, y is minus r, and when x is r, y is 0. So this is how the values of x and y coordinate changes. That means the x coordinate is actually going from plus r to minus r and then back to plus r as the object goes around the circle in one revolution. So basically the x coordinate is oscillating from plus r to minus r. So the one revolution will corresponds to one revolution in the circle corresponds to one oscillation of the x coordinate and one oscillation of the y coordinate. And if an object is moving like this, it follows this equation of motion, this is called a simple harmonic motion. Both. These are two simple harmonic motions actually. So this is one simple harmonic motion, this is another simple harmonic motion. So the uniform circular motion is actually a combination of two simple harmonic motions. That means we can see that when you do x square plus y square, we get r square. So this is the path of the object moving in a circle. So the simple harmonic motion is nothing but the displacement follows this law. X is equal to r cos omega t. Here we have seen is angular speed, or this is also called angular frequency. This r, we have seen that it goes from r to plus r to minus r. So this is called amplitude. Amplitude of oscillation. The x coordinate is oscillating with an amplitude of r. It goes from plus r to minus r. Same is true with x amplitude as well as y amplitude. Is equal to is r. But if these two simple harmonic motions are having different amplitudes, then we will not get a circle, but we will get, suppose instead of r, we are having x is equal to a cos wt and y is equal to b sin wt. Then you can see we will get x square. Let me use the small by a square plus y square by b square is equal to 1. That means if a particle is having combination of two simple harmonic motions with different amplitude, what you get, it moves in an ellipse. The object moves in an ellipse if it is undergoing two simple harmonic motions with different amplitude. But if it undergoes simple harmonic motion with the same amplitude, and you get a circular path. Now we'll try to see, when it is going in a circle, what is the force which is responsible for this simple harmonic motion of the x coordinate and simple harmonic motion of the y coordinate. And we know when the object is moving in a circle, it is under the influence of a centripetal force, and in the case of the sun and earth, it is a gravitational force. But suppose you are whirling a stone in a circle, then you are applying the force. But there is a force which is directed towards the center, and we know this centripetal force actually is also the origin of the force may be gravitation or applied by some external agency, but the centripetal force also is given as centripetal force, F centripetal, let me call it, is also given as mv square by r, where the acceleration is v square by r. The acceleration of, let us use the same capital R, the acceleration of an object which is moving in a circle, even though the speed is the same, but because the direction is changing, the velocity is changing, so the acceleration is v square by r, and here it is directed towards the center. So I will try to use this as r, unit vector, and minus, vectorially representing, because this is directed towards the center. So v is a minus v square r. So what we try to do is, now we try to see, this is for the central force. Now try to resolve this force in two directions, x and y directions. So what do we get? Ax is equal to minus v square by r. So if there is a force directed in this direction, then suppose if this is theta, then that will be minus v square by r cos theta. Ay is minus v square by r. Sorry, we are using the capital, so let us use capital sin theta. So because both being simple harmonic, and we will discuss only with this example because both are same. So here what is cos theta? Cos theta is nothing but x by r. This is x. When it is theta, this is x, this is x. I think let us make another circle so that it is more clear. This is x and this is theta. So we will plug in this into this, so into this equation. So what we get is, we get Ax is equal to minus v square by r. Cos theta is x by r. So what we get is minus v square by r square. X, this becomes x. So here we have the force when it is proportional to minus displacement, that gives rise to the simple harmonic motion. When a force is proportional to the displacement and acting against the displacement, then the object executes a simple harmonic motion. Here we are talking about the x coordinate. So if the same force is acting on an object, for example, if we are having a spring, when you stretch a spring, there is a force which will act against the displacement and proportional to the displacement. So this will execute a simple harmonic motion. So here we have derived the nature of the force which is responsible for simple harmonic motion, and it shows that the force is proportional to the displacement and directed against the displacement. So the simple harmonic motion, we have the force proportional to the negative of displacement, and that's why it is called a restoring force, because when you are trying to stretch it, it is trying to pull back, so that's why it is called a restoring force. The simple harmonic motion is executed when there is a restoring force acting on the object. So the simple harmonic motion is due to restoring force, and it has an amplitude, in this case r, but generally when we discuss we use the symbol A for amplitude. In general simple harmonic motion cases there is an amplitude, and then we have angular velocity or angular frequency, which is W. So here because we know that V is equal to RW, so this is angular frequency, which is nothing but, because if one rotation, when it makes 2 pi, one rotation gives us 2 pi angle, so omega is nothing but 2 pi by t. Suppose if it takes time t, that is called the time period, that is which is required for one full revolution of the object around the circle, or if you take this circle, this is the time required for the x coordinate to go and come back, or for the object to move in the circle and come back. Okay, so this time, which is called time period, is capital T. Then omega is nothing but 2 pi by t, because this angle by the total time, this is the angular frequency, and 1 by t we know is nothing but, this is called frequency, is 1 over t. That means this is one revolution, the number of oscillations per period, because if t in t takes one revolution, in the number of revolutions in or oscillations in 1 second, t is the oscillations per second, no sorry, time period, time per oscillation, then F is oscillation per second, So F is 1 over beta. So in studying simple harmonic motion, we need to know, we'll again restate, simple harmonic motion, force is proportional to the displacement minus, then we have amplitude, then we have angular frequency, then we have frequency, then we have time period. These are the basic parameters which describe the simple harmonic motion. So which two, we can write this as A cos or sine omega t. So omega is the angular frequency, A is the amplitude, X is the displacement. So here in this we have understood that the force which gives rise to simple harmonic motion is proportional to negative of displacement. Hope this makes it clear, the subject of simple harmonic motion.